Ever wondered how robots master tasks as tricky as handling a squishy sponge or twisting a knob without being handed explicit instructions? What if they could learn just by watching videos? Enter EasyFlow, a revolutionary approach in robotics that's redefining how machines interpret the world. Let's unpack this breakthrough and see how it's paving the way for smarter, more adaptable robots. Traditional robotics relies on labeled datasets, essentially step-by-step blueprints for every movement. But creating these is labor-intensive, costly, and limited by predefined scenarios. Imagine teaching a robot to cook by only giving it a recipe card, not the actual experience of chopping or stirring. EasyFlow flips this script. Instead of rigid instructions, it leverages unlabeled videos, like the ones we stream on YouTube, to let robots learn through observation. Most systems focus on objects, tracking their positions and interactions. But soft, deformable objects like sponges, hidden items, or dynamic actions like pressing a button, those are computational nightmares. It's like trying to learn cooking by only watching ingredients, not the chef's hands. EasyFlow sidesteps this by focusing on the robot's own body, its limbs, joints, and motion patterns. Think of it as teaching a robot to dance by analyzing how its limbs move, not the music or the audience. Here's the core of EasyFlow's genius. It predicts two critical elements. First, optical flow, a technical term for the movement of pixels over time, which reveals how the robot's limbs are moving. Second, a goal image, a predicted final state of the scene once the task is complete. For example, if the task is opening a door, the robot doesn't just flail randomly. It generates a mental image of the door open, and uses that to plan movements that are both physically feasible and purposeful. This dual predictive framework ensures actions are grounded in reality, while aligning with the task's end goal. In rigorous tests, EasyFlow outperformed traditional methods by up to 80% in complex scenarios. Think of tasks like folding a towel or navigating a cluttered table, where objects shift or obscure each other. Unlike older systems that might hallucinate movements or fail when faced with unexpected obstacles, EasyFlow adapts in real time. Its ability to handle occlusions and deformable objects stems from its focus on motion patterns rather than static object tracking. Here's where it gets even cooler. Researchers trained EasyFlow using human videos from the internet. By combining just 2 robot demonstrations with 50 unstructured human videos, they achieved a 70% success rate in tasks like grasping and manipulating objects. This hybrid approach lets robots absorb real-world motion diversity without needing labeled data. It's like giving a robot a library of human movement to learn from. No instructions, just observation. This isn't just incremental progress, it's a paradigm shift. EasyFlow's embodiment-centric design enables robots to handle deformable objects, navigate dynamic environments, and even infer task intent. Picture a robot chef learning to flip pancakes by analyzing cooking tutorials, or a warehouse assistant adjusting its grip based on visual feedback. The implications span healthcare, manufacturing, and beyond, where adaptability is key. So next time you see a robot performing a complex task, remember, it might be learning from videos, not code. EasyFlow is proving that robots don't need explicit instructions to master the world. They just need the right tools to watch, learn, and adapt. Stay curious and keep exploring the future of AI, because the next breakthrough is just a video away.